Hello, so continuing on this biweekly contest 15, the second problem that I'm going to do here is remove covered intervals. Remove covered intervals. Okay, so what does the problem say? So given a list of intervals, remove all intervals that are covered by another interval in the list. So it's covered if C is smaller than A and B is smaller than D. So it's contained in it. Probably some sorting, just sort the intervals. So if we sort the intervals, what do we get? Are they sorted initially? No. So if we sort them, and we could just go through them, right? So this will start by start, and if they are equal, it will sort by end. Let's just first print and see what we get. So 1,4 is not contained, right? But 2,836 is contained, right? So I think we'll need to somehow keep track of a start and an end, which is intervals. We have at least one interval, so we need to also have res, right? Some kind of a result. And we'll need to say I equal to 1, right? So while I is less than the length of intervals, I would say maybe don't sort using the normal sort order. Maybe instead sort using, let's say, custom things. So key would get lambda for x, right? And then we'll sort using x0, of course, but using the minus x1. So that would mean we'll get the one that covers it first. Okay, so so print that as res start, and so while it's less we need to check if intervals. So next. So maybe this is current start and current end, right? So if current start is less, or maybe just call it current, right? So if current 0 is, let's say if, so this is CD maybe, right? And this is AB. So if C is and B is contained, leave just AB, right? Don't add it, right? Otherwise, well, then add it, right? Add it and move on. Res.append AB and say current is equal to intervals I. And go to I plus 1. And here, well, we will need to say current. Just leave current as it is. Here just continue. No, do I plus 1. Pretty much. And just skip that interval because it's completely covered. Otherwise, move to the next one. Oh, we need to return the remaining intervals. So we don't actually need to return the interval themselves. So okay. Okay, that's bad. So this here should say 2, but mine says it's covered. Well, it shouldn't say that because, well, let me print back intervals, right? Because, and maybe maintain these. And let's see, why does it say it about that one? Okay, so it's sorted, and then its AB would be 0 and 10, and then we would find that, well, C is 5 and 12, so 5 is definitely, so 5 is not less, right? So we should be here. Oh, the problem is I don't count the last one. Yeah, that's the problem. I didn't count the first one, so, well, here I'm skipping this one, but This is really bad. Yeah. Okay, what if I just go back to append and just goes append AB. Oh, the last one, actually. It is the last one, so... How about instead keeping track of the contained, you know? So contained, of course, like that. So here you would append CD, right? You want to do that. And at the end you will just return the length of intervals minus the length of the contained ones. What? CD. So I starts out as 1, this is 0, get I. Why didn't that happen? So for 1 and 4, 1 is before 2, 8, 3, 6, so 3 is actually 3 is, no, it's the reverse actually, so yeah, so this is CD, this is EB, and the covered one is the EB. What? Okay, let's see. So AB is covered by CD because here C is 3, which is smaller than, not small, it needs to be 3 is bigger, right? So if C is smaller, so 2 is smaller than 3, that's good. And then B needs to be smaller than D, and B is 6, which is smaller than 8. So we should append to contained, and we should get that, right? So why aren't we getting it? That's impressive. So AB should be, so right now it's AB is 2H, so that's fine. So the current becomes, oh yeah, that's the problem. This needs to be CD. Okay, now that's what it is. Awesome, cool. Okay, so now let's try to see how other people solved it. So the way I did it is just by going through here and sorting them, and then finding the ones contained in other ones, and then returning the difference. Let's see if there is another way to do it. So this one seems very similar to all intervals must have different bounds. After sorting, their left and right bounds are increasing at the same time. So sort the array and note the previous left and right bound for every V interval. There is a new uncovered interval, so increment res. So this is very similar, I think, to my solution, right? Yeah, I thought about that, doing the sorting by the second one. Okay, so this is after removing all covered intervals. All intervals must have different bounds. Okay, so basically imagine that after removing all covered intervals, all intervals must have different bounds. After sorting, their left and right bound are increasing at the same time. So left and right bound so V0, there is a new so different after sorting the left. So we want the right to be, we want the first to be smaller than the first for the second, and then we want the last of the first to be smaller than the last of the second, to be bigger, because we want to have the uncovered next to each other. So that's why we do this. And then after that, if and not the previous left and right bound for every interval. So if j, which is the, so these are the intervals, if j is bigger than the previous right, the biggest right we have, if j is bigger, that means we have a new uncovered interval, because we know that I is smaller. We know that this I is bigger than the previous I. No, this is still confusing. Yeah, I think I need to draw this up. Okay, let me see. So the covering, he collects them in a dictionary, and he keeps subtracting the good ones. Subtracting the covered ones from the good ones. We assume that it's first the entire length. This is similar to what I did. And so he goes through the interval and then enumerates the rest and compares every two. And just doesn't need to worry about the indices. Perfect. And that way he doesn't even need to worry or think about indices problems. Definitely. So let me try.
Can be nice.
What was, yeah, I probably should do that. Sounds good account. I'll check them out. Make sure they're.
Okay, so let me just. Okay, so just simplify it essentially, but if I look at my solution again that passed the test cases, it was this one. And let's go with this here, solution 2. And
So for a long time, he's playing some game though. Mac out on.
Okay, so that's interval sort, and then, well, what we can do is, okay, let's just count the contained ones, right? Let's count the contained ones, and so keep that, and then just say for I and AB. Not sure why he needs that covering dictionary, because he's not using it. So enumerate interval. So this will give us the index and we do it for the other one, which is CD. Since we sorted, if one is uncovering, the other is potentially AB, and so here the intervals, and we check if I is different than J, C is equal, and B is less than or equal to D. At that point we say contained plus 1. say, and then in the end we could just return contained. So yeah, once we find one, why break then? Well, I think what I'm going to do instead is for G in range of I plus 1 length of intervals. I think this is easier for me to understand, and that way yeah, that way we can do CD is equal to intervals at J, and we could just return length of intervals minus contained, and that would pretty much be enough potentially. Well, it won't, we don't need to check this, right? So actually what should be here is that this is CD, this is EB. So this when you print should be 2. I don't think this is, yeah. Does it work though? So this one is not used, but why does it work? Okay, I'm not sure why actually this portion here work. Why is it? So it's interval I that is bad, that is covered. Is covered, right, by one of the other intervals. Oh, so for each interval, check if it's covered by another interval. Check if it's covered by another interval, and then if you find so interval E is covered by interval J, and that would pretty much break since it's covered. That's all we need. And then so remaining, so stop remaining -1, and then yeah, this is definitely easier to understand. Yep. Yep, I think this is, I can understand this a lot better, and that way we don't need this. Yep, we don't need this one, and this is a lot easier to understand. We don't need sorting even. Okay, so let me try to understand this solution here. So essentially what we'll be doing for this is, okay, well, let's say define a res and right? So what is right? That's a good question. What is right? Well, what is right? And then here we can sort the intervals by let me first understand what is this sort by key, which would be equal to a lambda function for x, and it would be first one, and then we want the smallest first, smallest ending first, right? So that if it's covered by the next, no, biggest ending first, so that if it overlaps with the next one, it must be smaller. It must be, so next one, it must be the next one, because ending, so that if it overlaps with the next one, then the first interval, then the second interval is covered by the first. So that's how we are, and so that way so the second is covered by the first. Okay, so so right would represent the largest largest ending of since we are guaranteed that a smaller largest ending of the interval that may potentially cover it, and so that way what will happen here is that we could say, okay, so we sort, and then we could say for I, j, and a, then in interval, right? So this would be two intervals we would add. So j bigger than right would mean that so j bigger than right, we need to increment, so I need to define this. So if j is bigger than right, that means I can increment by one res. J and so j is bigger than right. So, okay, so that means that, well, interval ending with I is ending with j, interval j, interval current interval starts after start is not covered by the previous largest one, which means it's good. It's a good interval, which means that we could here say right is equal to max of right and j, and we can return res. Think I got it, but I'm not sure.
Okay.
So if I submit this, okay. Yeah, I shouldn't forget to register. No, it's not this one. Maybe it's this one? Remove covered intervals. Maybe it's this one. Is it? Remove covered intervals. What? Maybe this one? Yep. Okay. So it's the... Which problem of the contest is it? It's problem 2, okay. Yeah, this is the second solution. Just go through 2 intervals and check if it has one that covers it, and that's pretty much it. Yeah, that's pretty straightforward actually. Yeah, this also is kind of good because, well, at least you don't have to think a lot to do it, because I like that. So you could do, okay, for u, which is, let's say, this in intervals, right? And for v in intervals, right? And then you count them, right? And then you check. Well, if, let's call these without thinking about it. B, C, D. Now if A that is less than C. Now actually this is C, D. No, this is C, B. So C, A and B, D. Then you count 1, and then here, once we are done, if so res equal to 0, only if the count, if there exists only one of them, then res plus 1. And can return here res, right? The good ones. So that's the good ones, right? And that's what we want to return at the end. And let's see if this passes the test cases. Yep, cool. Okay, I think this is pretty much good enough. So let's go back to the discussion section. So that no interval can cover the previous one, right? So that if there is one that covers, it must be the first one. Whenever current rightmost bound is less than current rightmost bound is less. So this is this one. The next interval's right bounds. It means that the interval cannot cover the next interval, so update rightmost, increase the counter by 1. Right. This explains it in like layman terms. So it's like this. Let's call this current. and actually just to okay, let's make sure this still works.